Hi friends, let us look at question 19 2024 paper 2 Kcse. We are told that the following figure shows a tent, and you can see the figure the way it looks like. A little bit complicated, but it's okay. We'll look at how it's supposed to be done. Now all this instruction you see here has been plotted there. So I'm going direct to the question. You're told to calculate the height of the projection FC on the ground to 4 significant figures. So a projection of a point is a point that if I cast a shadow from FC, it will give me something here. Let me call this one is the level ground, because this part has just been elongated to this upper part, the lower part, just a tent. So the distance we're trying to look is the distance here from this point, the level ground, to this point. Now if I look keenly on my diagram, you realize that if I bring down a point here into the middle part, if this is 8, this part should give me 4, and this one also 4. And the distance from B to this point, the middle point, is the same as B to the point which is at the middle here. So this is 4, 4. Therefore, it means if I now adjust this formation there, I will be having 4 on this side and 4 on this side. So by using this, I can get this distance. So here I was just supposed to say that 4 squared plus 4 squared, then this one should give me the projection of FC squared. So we have 16 plus 16, then that one is 32. Then you find the square root of 32, which is, to the nearest 4 significant figures, 5.657 meters. Then the height of the ridge EF, the height of the ridge above the ground. So they want this distance here, this distance. Now let us come to this figure here. Now the distance from A to B, it is 11. And the distance in between here, it is 3. So it means that if I have 3 here, and the whole distance from here up to this point, it is 11, it will be 8. So you see what we were still saying here, because this is 4. How did we get this 4? Because this is 3, and we are looking for the distance from A to the point here, the middle point A to this point. So it will be that 11 minus 3, that is 8. Then I divide by 2 because the distance are the same. Therefore, this side is 4 and this side also is 4. So if I want to find EF, this height here, this height, what we are going to do, we are going to make an arc of 90 degrees at this point, because we already have this distance here. So if I can write this point as 5.657, it's like a right angle triangle. Let me try to extract it here so that we can have it well. So we have 5.657, and this side we have 6. Then I'm looking for the point F to the level ground. That is the height going all the way down the level ground, somewhere here. So all this height. So first I can find this, because this one already we have as 2.5. So to find that, we are going to apply Pythagoras theorem. So we say 6 squared minus 5.657 squared. Then we find the square root. So by doing that, we are going to have 1.99958. But remember, we're supposed to give our answers to 4 significant figures. It is approximately to be 2.000 centimeters meters. Now that is the distance from F to this point. So I can now add what I have, 2.5. So I add 2.5, so that the total height above the ground will be 4.5 meters. That is how we get the 3 mark. Then we proceed on. They want the angle between the edges FB and FC. Now FB and FC. So it's good to extract the triangle so that we have our F here, B, and C. So since F is the common point, so that is the angle that they're talking about, is that we know that FC, it is 6, and according to the instruction, FC is the same as FB. They're equal, so all of them, they're 6. Then we have BC, which is 8. So here you can use many methods. You can use cosine rule or you can use sine rule, because this one it is 6 6, so it's an isosceles triangle. So let me just cut this into 2 so that I can first get this, then I multiply by 2. So I can just say 2 times, if I cut into 2, this one is 4, so that I have the opposite 4, and hypotenuse, because this is 90 degrees, hypotenuse 6, so opposite and hypotenuse, that is sine. Therefore it is the sine inverse of opposite over 6, but I'm multiplying by 2 because of the other side. You can use cosine rule, but I'm just using the sine rule. So if you press this one on the calculator, we're going to have 83.62 degrees. It's an angle. Then we go to the last one, where you are asked to find the angle between the plane FBC and the ground. The plane FBC and the ground. So the plane that is on the ground, it is this part here, and we can originally see it through this point. We know that this distance, it is 4, and the distance from F to the ground here, F to the ground, it is 2. The one that we found here, 2. Remember when we were calculating this part, F is the point F to our point ground, it was 2, approximately to be 2. So we are going to say, because the angle looks like this, so we have 2 and 4. So here we are going to apply the angle we are looking for, is this angle here. It is opposite and adjacent. So opposite and adjacent, that is tan. So we'll say that tan, because it's an angle inverse of 2 over 4. So the angle theta there, the angle FBC to the ground, will give me 26.57. That is how the question was supposed to be tackled, a little bit complicated. So that is 3-dimensional geometry in form 4. Thank you very much.